Burmese pythons have transformed the entire ecosystem of South Florida. After arriving here as seemingly innocent pets, these snakes have overrun their new environment in just a few decades.
In Florida's wetlands, Burmese pythons once spread quickly, becoming one of the most feared predators in the wild. These snakes could grow very large and eat animals much bigger than themselves. For years, people worried about their rising numbers. But now, something strange is happening. Scientists have found that these powerful snakes are slowly disappearing. They are not just dying naturally. Something is hunting them, changing the balance of the ecosystem in a quiet but serious way. This discovery has surprised many experts. What animal could possibly take down a giant python? And how did this begin? Join us as we explore this mystery. A mystery no one expected. Somewhere deep in the Florida Everglades, a quiet and puzzling moment unfolded that left a team of researchers without clear answers. A trail camera had been carefully placed near a specific GPS location. This was not random. The spot had been under close watch for 4 days, as part of an ongoing effort to track animal movement in the area. Everything had been working as expected at first. Then, suddenly, the signal stopped. For 2 nights, nothing came through. The most natural explanation was simple. The team believed the equipment had failed. Devices in harsh environments often stop working. Heat, moisture, and rough terrain can easily damage sensitive tools. So, when a biologist made the journey back to the location, the expectation was to fix or retrieve a broken tracker. Reaching the spot was not easy. The path led through dense sawgrass, thick and sharp, making every step slow and careful. But when the biologist finally arrived, what they found did not match their expectations at all. The tracker was still there. It had not been moved. It was still attached. Even more surprising, it was still working perfectly. But the animal it had been tracking was lying nearby, and what lay before them was deeply unsettling. The body was fully intact. A long, powerful form stretched across the pine needles and mud. It was a Burmese python, one of the most feared and dominant invasive predators in North America. The snake measured about 4.5 meters in length and weighed around 40 kilograms. It was a creature built from pure muscle, known for its strength and ability to overpower large prey. Yet something was terribly wrong. The snake's head was completely gone. There were no signs of a struggle. The body showed no wounds, no cuts, no marks that would suggest a fight. There were no drag marks leading away from the scene. There was no blood trail. The area was strangely calm. The snake lay still, surrounded by silence. Pine needles were scattered over its body, almost as if something had tried to cover it quickly. The research team gathered around the carcass. They stood there for a long time, quietly taking in what they were seeing. No one spoke at first. It was not just the condition of the snake that troubled them. It was what the scene suggested. Burmese pythons are known to have no natural enemies in this environment. They have long been considered an unstoppable force in the Everglades ecosystem. If that belief was true, then what had happened here did not make sense. Something had changed, but no one knew what. For years, Burmese pythons have caused damage in the Everglades that once seemed impossible. Their presence has deeply affected the balance of life in the region. Raccoon populations in areas where pythons are most active dropped by more than 99%. Opossums saw a decline of 98%. Marsh rabbits, which had lived in these lands for thousands of years, nearly disappeared. The impact did not stop there. Bobcat numbers fell by almost 90% in affected zones. Studies confirmed that at least 24 species of native mammals and 47 species of birds became prey for these snakes. The scale of this change has been enormous. The Everglades itself plays a very important role beyond wildlife. It serves as the largest natural water filtration system in the United States. More than 9 million people depend on it for clean water. When the food chain that supports this system began to break down, the effects spread across the entire ecosystem. The changes have been complex and difficult to fully understand. Scientists believe it may take a century to grasp the full impact of what has happened. The balance of nature in the Everglades has been deeply disturbed. Efforts to control the python population have been strong and ongoing. In the year 2017, Florida launched a python elimination program. Since then, more than 14,000 pythons have been removed from the wild. This number may sound large, but it has not been enough to solve the problem. Each year, the Python Action Team organizes a public hunting event known as the Python Challenge. Hundreds of registered hunters take part, hoping to capture as many snakes as possible. The prize money can reach $10,000, attracting wide participation. In the most recent competition, hunters captured 294 pythons in just 10 days. This was a record-breaking result. Even so, researchers say clearly that these efforts are still not enough.
It looks like there's a couple good eggs in here. This for so long. Oh no, this does not look good at all. Python laid her clutch eggs. Last year she had 14 good eggs. Things aren't looking too good.
The reason is simple, but powerful. Burmese pythons reproduce at a very high rate. A single breeding female can lay up to 100 eggs in one clutch. This means that even when many snakes are removed, the population can quickly recover. Within one reproductive cycle, the numbers can return to where they were before. For decades, this pattern has continued. Human efforts have struggled to keep up with the speed of the python population's growth. The numbers simply do not favor control. Because of this, when researchers began to notice something new in certain monitored areas inside Big Cypress National Preserve, they did not react with excitement. Instead, they felt concern. The data was showing something that had never appeared before. It was unexpected and difficult to explain. Rather than celebrating, the first question they asked was simple and serious. What did we miss? Something in the environment seemed to be doing what years of organized and well-funded human effort could not achieve. Something hidden within the sawgrass had been there all along, unnoticed. The discovery of the headless python raised a possibility that challenged long-held beliefs. If Burmese pythons truly had no natural enemies in this ecosystem, then this event suggested otherwise. It pointed to the presence of an unknown factor, something that had quietly changed the balance without being seen. The Everglades, with its vast stretches of wetlands and thick vegetation, holds many secrets. Much of it remains difficult to study closely. It is a place where visibility is limited and movement is slow. This makes it possible for important changes to go unnoticed for long periods. The situation now calls for careful observation and deeper study. Researchers are not rushing to conclusions. They are looking closely at patterns, data, and physical evidence. Every small detail matters. Understanding how the Burmese python became so established in the Everglades requires looking directly at its biology. These snakes are strong, adaptable, and capable of surviving in challenging conditions. They can go long periods without food and are skilled hunters. Their ability to remain hidden makes them even more effective. All of these traits help them spread and dominate the ecosystem over time. But now, something may be interacting with them in a way that had not been seen before. The discovery in the Everglades is not just about one snake. It represents a possible shift in a system that has been under pressure for many years. Whether this change will help restore balance or create new challenges is not yet clear. When the numbers began to change. An adult Burmese python can grow to a length of 16 feet and reach a weight similar to that of a large motorcycle. Its body is powerful and built for survival, and its jaw can open wide enough to swallow a white-tailed deer in one piece. After consuming a large meal, its body goes through a remarkable physical change. Its heart expands by about 40%, allowing it to push enough blood through its system to process and digest the food. This ability helps it handle meals that are far larger than what most animals could manage. This snake moves through sawgrass with almost no disturbance. It does not create ripples or noise that would give away its position. It moves slowly and carefully, without any sense of urgency. For about 40 years in the Florida Everglades, it lived without facing any natural predator that could hunt it. This lack of threat allowed its population to grow steadily over time. Estimates of the Burmese python population in the Everglades are wide. Conservative numbers suggest between 100,000 and 300,000 individuals. Some scientists believe the true number may be much higher. The exact figure remains unknown because these snakes are extremely difficult to detect. They can stay completely still for long periods, sometimes for weeks at a time. Their skin patterns blend perfectly with the ground and surrounding plants. Even trained hunters can walk very close to one without noticing it. For many years, efforts to deal with this growing population focused only on removal. Hunters were sent into the environment to capture and eliminate them. Trapping programs were expanded to cover more areas. Organized events encouraged people to participate in removing as many snakes as possible. These efforts did produce results, and many pythons were taken out of the environment. However, the overall population did not show a lasting decrease. New snakes appeared to replace the ones that had been removed, often before the end of each season. The population seemed to remain stable despite continuous efforts. Over time, the surviving snakes also became more careful. They adapted by becoming harder to find and more aware of their surroundings. Trail cameras placed across the Everglades continued to record movement. Year after year, these cameras showed activity in the same zones. The pattern did not change in a way that suggested a clear reduction. The situation appeared to have no natural limit, and the problem seemed to continue without a clear solution. While most attention stayed on removal efforts and how to improve them, another development was quietly taking place. It was not immediately noticed because it did not fit into the usual way researchers were studying the problem. The signs were there, building over time in areas that had not been closely examined for this kind of change. Dr. Elena Marsh had been working in Big Cypress for 7 years, focusing on population density surveys. Her approach was steady and consistent. She used the same methods across all her studies, allowing her to compare results clearly over time. Her findings showed that the presence of pythons was either holding steady or increasing in every zone she monitored. Then, over the course of 4 consecutive seasons, something unusual began to appear in her data. In 3 specific zones, the detection rates started to decline. The change was not sudden or dramatic, but it was steady. Each time the results came in, the numbers moved slightly downward. The pattern repeated itself consistently across all 4 seasons. This change raised important questions. There had been no new removal programs introduced in those areas. Hunting pressure had not increased. There was no clear external factor that could explain why fewer pythons were being detected. The methods used to collect the data had not changed, so the results could not be explained by differences in how the surveys were conducted. Dr. Marsh spent 3 months carefully examining every possible explanation. She looked at environmental factors, survey conditions, and any changes that might have influenced the results. Each possibility was considered and then ruled out one by one. The decline in detection rates remained unexplained. After exhausting these options, she decided to take a different approach. She returned to the trail camera archives, but this time she looked at them in a new way. Instead of focusing only on python movement, she paid attention to what was happening around the pythons. She shifted her focus from the snakes themselves to the wider environment captured in the footage. As she reviewed the recordings, patterns began to appear. These patterns had been present for years, but they had not been noticed because no one had been looking for them in this way. The information was already there, quietly recorded in the background. What she found across these archives marked an important turning point. It introduced a new way of understanding what was happening in the Everglades. The focus moved beyond simple removal numbers and began to include changes within the environment itself. This discovery brought a different perspective to a problem that had seemed unchanged for decades. The steady decline in detection rates in those 3 zones suggested that something was influencing the python population in a way that had not been previously considered. The evidence did not come from a single event or a sudden shift. It came from small, consistent changes observed over time. These changes only became clear when the data was viewed from a broader angle, one that included the surrounding ecosystem rather than just the target species.
Burmese pythons have done unprecedented damage to the ecosystem in South Florida, and experts say these invasive snakes continue to move farther north.
The situation in the Everglades had long been seen as a challenge, without a clear limit or endpoint. The python population appeared to grow and sustain itself despite continuous efforts to control it. The new findings suggested that there might be factors at work that were not part of the original strategy. By looking beyond direct removal and focusing on the environment as a whole, a new layer of understanding began to emerge. The signs had been present for years, quietly building in the background, waiting to be noticed. This shift in perspective did not come from a change in tools or technology. It came from asking a different question and looking at the same data in a new way. The discovery showed that even in a situation that seems unchanged, important developments can still be taking place. The Everglades remained a complex and challenging environment, but the steady changes observed in those zones suggested that the story was not as fixed as it once appeared. The data, when carefully examined, revealed that something meaningful was happening beneath the surface. Changing interactions with Burmese pythons. The bobcat is a wild cat that weighs between 7 and 14 kilograms. This size places it far below the weight of a mature Burmese python, which can be many times heavier. In fact, a bobcat weighs roughly 1/10 of a fully grown Burmese python. Because of this large difference in size, scientific studies had never suggested that a bobcat could create any meaningful pressure on a large constricting snake. The general belief was simple and clear. A predator of that size would not be able to challenge such a powerful reptile in any serious way.
May have found the perfect egg eater for the job.
The bobcats are helping us out.
We have another hunter out there, so if we can get the nest taken out before they even get a chance, that's fantastic. We couldn't ask for more than that.
However, footage collected from monitoring zones has shown something very different. These recordings have provided clear and direct evidence that challenges what had long been accepted. In the year 2021, at a location known as Big Cypress, a camera captured a moment that stood out in a very strong way. The recording showed a bobcat moving toward an active python nest. Instead of avoiding the area, the bobcat approached with purpose and focus. The actions of the bobcat were careful and steady. It did not rush or act without thought. It began to destroy the eggs in a methodical way, one after another. This alone was already surprising, as such behavior had not been expected from a predator of its size, but the situation became even more striking when the female python returned to defend her nest. At this point, many would expect the bobcat to retreat. The python was much larger and capable of delivering a powerful strike, yet the bobcat did not withdraw. Instead, it adjusted its position again and again, always staying just outside the distance where the snake could strike effectively. The bobcat appeared to read every movement of the python with great attention. It remained alert, careful, and controlled. Over time, this steady behavior had a clear result. The bobcat managed to push the much larger snake away from the nest entirely. A snake that weighed about 5 times more than the bobcat was driven off from her own nesting site. This moment was not only unusual, but also deeply important for understanding how these animals can interact. Wildlife biologist Ian Bartoshek later reviewed the footage. His reaction reflected what many in the scientific community were thinking. Seeing an 11-kilogram cat stand its ground against a 40-kilogram python was something that existing research had not prepared anyone to expect. It showed that earlier assumptions about size and dominance did not fully explain what could happen in real situations. By the year 2025, the observations had gone even further. Interactions between bobcats and pythons were no longer limited to nests or defensive encounters. There were now clear records of direct hunting events. In one documented case, a bobcat successfully hunted and killed a python that was nearly 4 meters long. This snake was about twice the body weight of the bobcat itself. After making the kill, the bobcat handled the situation in a way that matches its known behavior with other prey. It cached the body, storing it carefully, and returned to feed on it over several days. This detail shows that the bobcat treated the python as a regular food source, not as a rare or accidental target. The interaction was active, planned, and effective. While the role of the bobcat was already surprising, it was only one part of a much larger pattern being revealed by the monitoring cameras. Another animal began to appear in the data, one that had never been linked to python control in any meaningful way. This animal was the river otter. River otters are small, active, and closely connected to water. They are known as aquatic feeders and are usually associated with fish and similar prey. Before these observations, nothing in their behavior suggested any link to large constricting snakes. They were not considered part of any discussion related to python population management. Yet, in the waterway zones within the monitored areas, Groups of river otters were recorded doing something unexpected. These groups ranged from 4 to 12 individuals. Instead of ignoring pythons, they were actively targeting them. Their focus was not on large adult snakes, but on younger individuals and nests located near water. Newly hatched pythons are small, measuring between 40 and 60 centimeters in length. At this early stage of life, they are weak swimmers and have very limited ability to defend themselves. This made them vulnerable in environments where otters were present. The recorded behavior of the otters showed a high level of coordination. They approached from multiple directions, working together as a group. When they encountered hatchlings, they pulled them underwater. They then used a spinning bite technique, a method they normally use when handling fish. This action allowed them to apply a level of force that went far beyond what their body size might suggest. When a group of otters located a python nest, the result was quick and complete. They consumed the eggs rapidly, often clearing between 60 and 100 eggs within minutes. This was not a slow or occasional action. It was fast, focused, and highly effective. The impact of this behavior became clear when looking at survival data. In areas with high otter activity, the survival rate of young pythons during their first year dropped sharply. The rate fell below 15%. This is a very low number and shows a strong effect on the population. These events were not random or accidental. They were repeated and consistent. The otters were not simply taking advantage of rare opportunities. Instead, they were removing entire groups of young pythons before those animals could grow and become part of the breeding population. This created a clear and measurable change in how many pythons could survive and reproduce. Beyond the actions of bobcats and river otters, there was a third pattern that drew attention. This pattern helped explain a strange and repeated observation. In some areas, researchers began finding python bodies with a very specific condition. The snakes were missing their heads. This was first noticed around the year 2021. The Florida Fish and Wildlife Conservation Commission began to document these findings in a careful and detailed way. The pattern was clear. Adult pythons were being found with their heads removed, while the rest of the body remained mostly untouched. The way the head was removed did not match known attack patterns from other predators. It was not similar to what is seen in attacks by alligators. It also did not match the feeding patterns of panthers. Instead, the removal was precise, leaving the rest of the body largely undisturbed. To understand this, researchers used detailed analysis. They studied bite marks, jaw angles, bite force, and the spacing of teeth. They also examined the shape and structure of the wounds. Each of these measurements provided important clues. The results pointed in a clear direction. The animal responsible for these actions was estimated to weigh between 11 and 16 kilograms. This is a size range that does not usually attract much attention when compared to larger predators. It is an animal that most people would expect to avoid such large prey. Yet, the evidence showed that an animal within this size range was capable of removing the head of a large python with precision. This finding added another layer to the growing understanding of how different species interact with pythons in these environments. How coyotes are learning to challenge. Coyotes do not rely on physical strength to face Burmese pythons. Instead, they depend on perfect timing. Burmese pythons go through several biological stages where they become extremely vulnerable, and most people are not aware of these moments. These short periods create opportunities that a smart predator can use. After a Burmese python eats a large animal, its body begins a powerful digestive process. During this time, blood flow is redirected heavily toward digestion. This shift is so strong that the python's muscles lose much of their strength for several hours. Its ability to constrict becomes almost completely absent. In this state, even though the python is large and powerful, it cannot properly defend itself. Another vulnerable period happens during egg incubation. A female python stays in one fixed position to protect and warm her eggs. Her full attention is focused on the nest. Because of this, she cannot properly track movement behind her. Any threat approaching from the wrong angle may go unnoticed. The shedding cycle creates yet another weak point. During this phase, the python's eyes turn cloudy. This greatly reduces its vision. For a period of time, the snake is almost blind and cannot clearly see what is happening around it. In all of these situations, there is a specific weakness that can be used. A coyote approaching from a narrow angle behind the python's head, roughly between 30 and 45 degrees, can stay within a natural blind spot. This blind spot exists because of the snake's eye placement. From this position, the coyote can deliver a quick and accurate bite to the skull. The attack is fast, and the coyote can leave before the python is able to react. The brain of the python contains a high level of energy compared to other parts of its body. This makes the reward of such an attack very valuable. At the same time, if the timing and angle are correct, the risk to the coyote remains low. This balance of low risk and high reward makes the behavior effective. Coyotes did not originally arrive in Florida with this knowledge. This behavior developed slowly over time. Individual coyotes began by experimenting. Some approached weakened or distracted pythons and discovered that attacking the head at the right moment worked. When the result was successful, they repeated the action. Other coyotes observed these actions. Through watching and repeating, the behavior began to spread. Over time, it became more common within the population. This is not instinct. It is learned behavior that moves from one animal to another through observation and practice. Evidence of this pattern became clearer over time. From the year 2021 to the year 2023, the number of python carcasses missing their heads increased steadily. This rise matched the spread of this learned behavior among coyotes. This type of learning is similar to other examples seen in nature. Some birds learn to drop hard shells onto roads to break them open. Some marine predators learn special hunting methods through repeated attempts and observation. These behaviors are not present at birth. They develop and spread through shared experience. The result of this learning is now visible in certain areas.
The company Inversa uses AI to track python movements. It hopes to keep removing a substantial number of the invasive species from the Everglades. It said more than 1,000 snakes were removed between May and July of this year.
The pressure on Burmese python populations in parts of the Everglades is not only coming from human efforts. It is also coming from native animals that are developing new ways to hunt and survive. Different species are contributing in their own ways. Bobcats are learning how to understand python movement and take advantage of their limits. Groups of otters are learning to find nests and remove eggs before they hatch. Coyotes are learning how to approach from angles where the python cannot see them. All of these behaviors are spreading in the same way. Animals observe, repeat, and improve. Over time, these actions become more common across the population. This process remained hidden for a long time because no one was looking for it in the right way. It only became clear when researchers reviewed large amounts of camera data. These cameras had been recording activity for years, but the patterns were not noticed until the right question was asked. This does not mean that the problem of Burmese pythons is solved. Their population is still large, and they reproduce quickly. Natural predators and human removal efforts together are not enough to cause a rapid change. Control programs must continue, and the challenge remains very large. However, new data from 3 declining zones inside Big Cypress shows something important. It shows a shift in direction. For many years, the system was moving in only one direction, with python numbers growing. Now, there is evidence of change. This change did not happen suddenly. Burmese pythons did not become dominant in a short time, and the forces now working against them also took time to develop. These changes grew slowly and spread quietly. There were no large announcements or major programs behind them. A bobcat holding its position near a nest. An otter group removes dozens of eggs from a nest in a short time. A coyote moving carefully at night from the correct angle. These small actions were happening without attention. They only became visible when detection rates in certain monitoring areas began to shift in an unexpected direction. This led to a new question. Instead of asking what human efforts had achieved, attention turned to what the ecosystem itself had already learned. This shift in understanding reveals something powerful. Ecosystems are not passive. They can adapt over time. Animals can learn, adjust, and respond to changes in their environment. The story unfolding in the Everglades shows that change is not always loud or immediate. Sometimes it develops quietly through many small actions, building over time until it begins to shape the system in a new way. What do you think about these pythons? Share your thoughts in the comments, and don't forget to like, share, and subscribe. Before you go, be sure to click on the video shown on your screen.